Good afternoon, class. We are in Miss Aaron's room, and it is March 6, 2013. It is a beautiful Wednesday evening, and it is currently 6:40 p.m. I hope you guys are all happy that we're staying after school so that you guys can learn. I'm late for church, and my dad is probably going to kill me later, so this might be my last podcast. So I better get 15 extra credit points, even though I'm dead. But it should all be worth it, because you guys are going to learn something today, right? Well, I'm Esther Perales.
I'm Isaac Limon Camarena.
I'm Gabby Amador.
And I'm Beauty Gayeng Moi.
And today we are going to learn about ionic radius. Woohoo! All right.
Okay, so what is ionic radius? The distance from the center of an ion to the outermost ring. Ion is an atom with an electrical charge. Lose an electron, it becomes a positive. Gain an electron, it becomes a negative.
Here are a couple words you guys should know. The first one is the cation, and it's a positively charged ion. And when the radius gets smaller, it loses its electrons. And a good way for you guys to remember that is when you spell out the word cation, the T, positive charge. So remember, T, positive cation. And the second word is an anion, and it's a negatively charged ion, and it gains electrons. When it gains electrons, the radius gets bigger. And a good way to remember that is anion, the N for negative. So remember, negative N, anion. And another good rule you guys should remember is the octet rule. And it's when the atoms want 8 valence electrons in order to be happy. And all the atoms in the periodic table are going to react with one another in order to make sure they have 8 valence electrons. And when they do, sometimes they form ions.
All right, and here is just some examples. Up here in the upper right-hand corner, we have some very unhappy atoms because there are only 7 electrons in the valence shell. And so they're not satisfied because they only have 7. How sad. And in the bottom left-hand corner, we have some very, very happy atoms because the 2 valence electrons are shared. And this gives each fluorine atom an octet in the valence shell. So following the octet rule, which makes these atoms happy, happy, happy. All right, measurements. Take it away, Isaac.
All right, guys. My name is Isaac Limon, as you know. Oh, I'm parched. All right. Values of ionic radius are very difficult to obtain, and they are measured in picometers and angstroms. For those of you that don't know, an angstrom is 10 to the negative 10th meter, and 1 picometer, you should already know this from previous sections, is 10 to the negative 12th meters. Thank you very much. And another way to measure ionic radius is with X-ray calligraphy. Crystallography. It is an experimental technique that... Alright guys, let me just restart this right now because I was a little distracted by some graffiti in Mrs. Aaron's room. Alright, let me just take it from the top here. So X-ray crystallography is an experimental technique that scatters X-rays through an electron cloud of an atom. It is not an imaging technique, and X-rays are used because they have the proper wavelength to be scattered into an electron cloud. And based on the differentium pattern obtained from scattering these X-rays through this method, we can find out the electron density, and it can be reconstructed. So that allows us to find out the ionic radius. Plus, there is no size limitation when using this method. There's a picture for you to enjoy.
Sorry, Beauty, it's your turn.
My turn. Think you've taken over. All right. Ionic radius trends follows the atomic radius trend. The size decreases as you go left to right across a period, and it increases as you go down a group. Did I say increase or decrease?
I don't know.
All right, well, all right, so I'll show you here. As it goes left to right, it decreases. And as you go down a group, it increases.
All right, so let's try this out. All right, so let's see what happens to a radius of an atom when it loses or gains an electron. For example, right here, this one, we have sodium. And it has one valence electron in its outer shell. And sodium tends to want to give this valence electron away to somebody else. And when it does, it loses this shell right here. It loses that shell. The inner shell right here already has 8 valence electrons, so that atom is going to be smaller. So let's think about it. If sodium loses this valence electron and loses that energy level, it has just become a smaller atom because it gave this one away. And it became smaller. Fluorine, on the other hand, has 7 valence electrons on the outside, so it wants to gain one more from another atom, say from sodium, who likes to give one away. Well, when it gains that electron right there, that electron has a negative charge, as well as all of these also have negative charges. And as you know, like charges repel each other because they want more space. So this shell, this last orbital right here, is going to spread out a little more so that each electron can have more space. So the repulsion of negative charge in this shell right here is going to make this ion a little bit bigger because of the repulsion. Alright, so let's recap a bit. Cation, which is this one right here, are smaller than the original atom because they lose an energy level as electrons are being given away, so they become smaller. Anions are bigger than the original atom because when you add another negative charge, these negative charges are going to repel each other and the atom is going to get fatter so that each electron can have more space. So cations are smaller than the original atom and anions right here are bigger than the original atom. Alright, thanks for watching our video, guys. Oh no. We hope that you all enjoyed watching it as much as we enjoyed making it, and if I can get this music on, we will be good to go and I won't be as late for church. And I don't know, you guys should all be at church right now learning about the Lord. There we go. So thanks for watching.
Miss Erin, someone did graffiti on your wall, just so you know.
Graffiti?
Yeah.
Bye, guys.